Hi, welcome back to this demo lab. Today, I will show you how to make noise figure measurement using a vector network analyzer. Noise figure is defined as a degradation of signal-to-noise ratio between the input and output of a linear or quasi-linear component, circuit, device, and system. For the value of noise figure, the smaller the better. There are two methods to test the noise figure: Ceyear dedicated noise figure analyzer and signal spectrum analyzer adopt Y-factor method, or called cold-hot source method. The other method is called cold source method. This method, based on VNA, has the highest accuracy and costs the most. And this method can provide S-parameters measurement as well, with only one connection. To make noise figure measurement using VNA, we should first calibrate the measurement channel to get the internal noise receiver's self-gain and noise figure. Then, we can insert the DUT and read back the noise figure, gain, noise parameters, and other S parameters as well. Now, let's get started. Firstly, we insert the USB-powered ECAL into the source input and output of port 1. Here, the ECAL works as an impedance tuner, and we connected the standard noise source to the reference plane of port 2. Secondly, we create a noise figure measurement. We click on Measure class, and then choose Noise Figure Cold Source. We can see a noise measurement window is displayed on the screen. We then set the working frequency, noise bandwidth, IF bandwidth, averaging number, current temperature, and other parameters in these dialogues. Thirdly, calibrate the channel. We press Calibrate key and choose Noise parameter. We can follow the result step by step to make the noise figure calibration, and then make a traditional full 2-pulse calibration. Fourthly, we insert the USB preamplifier in the measurement channel. The port 1 is connected to the amplifier's input and port 2 to the output. We know the working frequency is from 100 MHz to 26.5 GHz, and the declared gain is 23 dB, and the noise figure is less than 5 dB. Then we can see the noise figure, gain, and other noise parameters are displayed on the screen. We can double-click a single window to maximize it with full screen. We set 4 marks that are displaying the noise figure less than 4 dB, and we can see the gain is well above 26 dB in the full frequency range, and other noise parameters are displayed at the same time. Of course, we can create a new window to display other 4 S parameters.